Hello again, this is Michał Strzeszewski, Sankom company, Warsaw. As it was announced, I'm going to present you the software for central heating design, Kan C.H Graph 3.6. C.H, it's for central heating, for heating systems in buildings, and graph because it's designed in the graphical form. Majority of data are entered in the graphical form, and additional data are entered in the tables that are dynamically connected with the graphics. And before we go to the details, let me present you the main features and the main possibilities and area of applications of this software. It's very flexible. You can design different systems. At the moment, you can see on your screens the example of the traditional vertical systems with the vertical risers and radiators connected directly to the risers with pretty short branches. You can find all these examples in the folder on your local disk, normally C, then it's CAN4, and then you've got subfolder data. This is the second example, and let me show you one small detail. With the shortcut Ctrl-Z, you can immediately see the whole range of the drawing, and as you see, we are pretty flexible. It means that you can mix different layouts, different concepts within one design. On the left-hand side, you can see two risers connected at a specific point, while on the right-hand side, this part of the system is the vertical pipe system, double pipe system, but a vertical one. The third example shows possibility of designing the manifold system with the flat manifolds. And as you see, we've got the manifolds, and then we've got the radiators in different rooms. At this moment, you can see the technique, how we draw this on the diagram. We draw the radiator, then the pipes, and we draw a relatively short pipe, horizontal pipe, and then in the table we enter the area, the total length of this pipe. In this example here it's 2 meters, and then we connect this pipe through this element, which is the distant pipe connection, distance pipe linking, because the diagram must be precise. The program knows exactly which pipe is connected with which one. Standard solution is that this distant pipe linking is not printing. You won't see them on the printouts. Okay, let me present you the next example. And this is the possibility of drawing in a pretty easy way the Tichelman system. This is the vertical system. As you see here, we've got the vertical pipe, the supply riser, whereas on the right-hand side of the drawing you can see the return riser. In fact, these risers are very close to each other in the same room, but we've got this possibility in the program that we can draw on the diagram one room in different places. This is, as you see, the zone of the staircase, and on the right hand side we've got again staircase. So these two zones that are drawn in the diagram as two zones, in fact there are this belong to just one zone of the staircase, but it was just easier to draw the Ticherman system in that way. Example 5 is the example of the mixed system. As you see, in one system we've got both traditional convection radiators, whereas in some other rooms we've got the underfloor heaters, radiators, and they are connected to one heat source but using the mixing models. This example presents also the possibility of presenting the plan views, because at the moment it's always obligatory to draw a diagram of the system, because this is the way of entering the data to the software. But optionally you can also import the files, for example from AutoCAD, the drawings of the buildings, and you can draw also the system on the plan view. Then you can link the system elements from the plan view with the appropriate elements in the diagram, and then after fulfilling the after carrying out the calculations, the program will present, for example, the pipes diameters, the sizes of the radiators, the presets of the valves, and so on, also on the plan views. If you are interested in designing the single pipe heating systems, I've got good news for you, because this program is not only for double pipe systems, it's also very flexible for designing the single pipe systems, both vertical and horizontal ones. Let me have a look at this example a bit in details. We've got the heat source, and then we've got the supply pipe, and we've got just one riser that goes to the top of the building, and then we've got the pipes, the radiators connected in series, so we've got the single pipe system. And as you see, first the pipes are drawn in red, because this is still a clear supply part of the system, and then this single pipe part of the system is drawn as brown, because in this case, in the single pipe systems, we just can't say whether it's a supply or return pipe. It has got both functions depending from which perspective of which radiators we observe that. And then water goes down. We can have bypasses as well. And after the last radiator, we've got again the blue pipe, because that's again clearly the return pipe. That was example 6. Now let's have a look at example 7. And here it's again the single pipe system, but in this case this is the horizontal system. As you see, the radiators are connected with one pipe. This is another example of flexibility of the software. We can have different solutions in different pipes or part of the system. We can have the radiators with bypasses, without, and so on. Another example, here the radiators are connected in that way. So really it's up to the designer what he invents, how he would like to connect the radiators. Then the program is analyzing that. Of course, the other question is what connection is reasonable. Always you have to remember that the software is only the tool for the designer. The software is not intended to substitute the designer. And the last example, as we can have a look at the general data, this is not really a heating system. If you have a look at the general data, you can see that here we've got the parameters of the cooling agent, supply temperature 6, a temperature drop or rise, in this case 6, so 6 for 12, because this software is intended not only for the heating system, it also can be used to design and balance the pipes, the pipe network for the cooling system. And the last example, example 10, is just for it. Okay, that was this introduction. Do you happen to have any questions at the moment? All right, I can't see any questions. So let me go into details. And oh, there is one question. Okay, the first question is if we are able to change the color of the layers. That is possible with some limitations. Let me present you that, maybe using example 1. And we've got here the tab graphics, and this is the button layers. This gives us the possibility to edit the layers, because as it was suggested in the question, the program used the technique of layers. So different elements of the systems are drawn on the different layers. And these layers have got the specific properties, the colors, of the style and the width of the lines, and so on. And let me, for example, standard solution is that radiators are filled with the yellow color, and you may happen not like that. So we can choose the layer of radiators, then choose the button Edit. And what color would you prefer for radiators? I can't see the answer yet, so maybe red, because they are pretty warm normally. And now we close, and as you see, all the radiators are now red. Okay, I can't see any more questions at the moment. If you happen to have any questions, you can write them all the time. Just it may happen that I will answer them in a few minutes. There's another question, whether it's possible to design a fan coil system with this program. With the current version, it's not possible to design the whole system, including the fan coil selection. However, it's possible to design the pipe networks. And the example of that is the example 10 attached to the program. So now we'll start the new project. So I choose File, New Data. Now there's a question whether for pipe fan coil system. No, at the moment not yet. At the moment only 2 pipe fan coil system. Okay, I have started the new project, and in all our applications there is this convention that there is always some kind of general data. General data refers to the whole project rather than a specific element. And to tell you the truth, we try to put as many data to general data as possible. Why? Because this data are entered only once. So first we've got some technical information, the name of the project, the project location, address, the designer, so I can put my name. These data are of course not obligatory. However, in the real designs it's good to enter them because then you will have them also on the printouts. Then very important data is the calculations variant. We can design the new installation, the new system, or we can adjust the existing one, or we can connect these two solutions. What's the difference? If we design the new system, then later on we choose the temperature of this, for example, 70 degrees supply temperature and 20 Kelvin pressure drop. It means that it's 70 for 50. And then the program tries to select also the area of the radiators, if possible, to achieve this temperature drop 20 degrees as close as possible. If we choose the regulation of existing installation, then very often it happens that we don't select the radiators. The radiators are already selected because the system exists in the real life. So we have to enter the sizes of the radiators, and then the program tries to adjust them to achieve the required heat load. And to achieve that, the program is capable of changing the agent mass flux, and that results, of course, in different temperature drops. So in this variant, to tell you in short words, the program is allowed to change this temperature drop. If in some limits, and these limits are in the second tab in the calculation parameters, and the standard solution is between 10 and 40. It means that if we adjust the existing system, then the program can select different temperature drop between 10 and 40 kelvins. It means that if it results that the radiator is too big, so the program can reduce the water flow, and that would result with the higher temperature drop. And if we've got the opposite situation, if the radiator with the current supply temperature is too low, the program can increase the water flow, and that would result in the lower temperature drop. Of course, as you know, taking into account the heat characteristic of radiators, normally we've got much higher possibility to reduce the heat load of the radiator rather than to increase it. Adam asks if we can change kelvins to Celsius. To tell you the truth, generally we use Celsius, degrees Celsius. Here we only use it kelvins for the temperature difference. Why is that? Because as you know, if we speak about the temperature difference, degrees Celsius and Kelvin is exactly the same. Only in Poland we've got a kind of convention that among engineers we believe that it's more elegant to speak about the difference in kelvins rather than degrees Celsius. However, it's exactly the same. So in fact, for the temperature difference, we don't. I don't think we need to change kelvins into degrees Celsius because it's exactly the same. Then we choose the type of agent. Normally it's water, but we can also use the glycols. Then we have to also write the concentration of glycol. But let's keep with water. And then we select the pipes. We can choose the producer, for example, the Kan, and for example, Kan Inox system. And the general principle in the program is that we select the pipes in the general data and we associate the specific pipe with this general symbol A, B, C, D. And later on, we use in the program, in the design, we use this short names A, B, C. And if we want to change, to try to design the same system with different pipes, we can come back to the general data and say that from now on, A, it won't be Kan Inox, it will be, for example, a PVC pipe. And then automatically all the pipes that were marked with the symbol 8 would be calculated using the other pipe. We have also include here the heat source parameters, pressure drop, for example, 500 pascals, and the water capacity, for example, 15 liters. And we've got one more data here, which is the disposal pressure. We may enter it, however, in many cases we leave this field blank. Why is that? Because disposal pressure, it's only if we already know it. For example, we have already selected the pump, or it's very useful if we design only the part of the system. For example, we design only the system in one apartment and we just know the disposal pressure, so we can write here. If we design the whole system, normally we leave this field blank and the program just calculates the appropriate pressure and then we select the pipe to that. In the general data, we've got also another tab, which is called calculation parameters. Here are the basic parameters resulting in the calculations. At this brief presentation, I won't discuss in details all of them, just to give you an example. Let's have a look at the first option. This is the maximal unitary linear pressure drop. So in pascals per meter, and you can design systems using different parameters. If you write here the lower value, for example, only 100 pascals, then that would result in the bigger diameters of the pipes and also the smaller pump. Opposite solution would be, for example, 250 pascals. It means that we allow much higher linear pressure drops, so the pipes may be smaller, the diameters will be smaller, but we would need a bigger pump. So if you analyze these parameters, then you can really influence the way the program can calculate that. However, for the beginners, I would suggest not to change the standard data, because if somebody does the changes without really knowing what he's doing, then the results can be really random or surprising. There is a question if we have to set the heat source parameters at the beginning. No, not necessarily at the beginning. I have already entered it just to show you. If you wish to do it very precisely, of course you even can't do it at the beginning, because the pressure drop depends on the volume and you don't know this value. So you can enter it later on, or you can enter just a kind of approximation at the beginning, and then you can enter the precise value later on when you know it. Let me come back again to the 4-pipe Funkel system. Just my colleague just helped me with some more precise information. At the moment, with the current version, we can't mix both the heating and cooling system, so we have to divide it and design it in 2 projects. And in the future version, version 4.0, that would be possible to do it within 1 design. Okay, so let's close. I forgot about one data, but as you see, it's not dangerous because the program reminds me. There's also the climatic zone. These climatic zones are made for Poland, so that won't be valid for your countries, but you've got then the possibility of choosing the appropriate external temperature. As you see, with pretty high range, up to minus 60, which I hope would be enough. Let's choose, for example, minus 22, and it's a good, always a good custom to save your file. I said we've got to wait a second. Yes, and let me remind you about one very useful option, which is autosave. The program has got the possibility to save automatically data. The standard value is 15 minutes. Let me put it, for example, 10. It means that the program would save the data every 10 minutes. If there is some problem, for example, with electricity, so then we won't lose more than 10 minutes of our work. Now, more and more often, we work with the laptop computers, which have got batteries, so the electricity problems are not so important as before. However, if you do the real designs, then it's also good to have pretty big screens, or very often we use 2 screens. That is just more convenient. Okay, and now let me show you how we draw the system. I will present you a very simple system. So first I have to draw the floors. So I choose the tab construction, and here we've got the ceiling system creation. For example, I need to ceiling or floor, it's the same in fact. Then the length. Of course, as you know, in case of diagram, we try to keep the vertical scale, and horizontal scale is rather random. We don't keep it. However, we enter some value because the program must know how long this floor should be. Then the height of the story and the thickness. You can have also this table, because it may happen that, for example, the first story is a bit lower because it's a cellar. And then I click OK. And this system of floors is in the clipboard, what you can see observing the cursor style. So I press it and Ctrl Z, I've got the whole system. If you need a staircase, so you can create another. Maybe now we've got only 2 floors. And as you see, I created pretty fast, relatively complex floor system. If you have a look at the coordinates, one coordinate is red. Why is red? Because it marks the 0. Wherever you put this coordinate, then you've got 0. If we assume that you've got the cellar, the lowest floor is cellar, and then we've got the first floor, the ground floor, so we would prefer to have 0 there. So it's very easy, you can just move. If you move the coordinate, this red coordinate here, so it says that here it's 0, we put another one underneath, and as you see, with this very simple steps, we change that. Now we say that here on the ground floor is 0, and in the cellar we've got minus 2.8. And then we need the room zones. So I choose the room zone. And the only thing you have to observe is not to do what I have just done. These room zones can't overlap each other, so I have to correct that. And normally we draw with the preciseness of 5 centimeters, which is enough to be precise, but therefore it's very easy to draw it in a clear way. And as you see, again, here there is a gap, 5 centimeters probably, but it's very easy to correct it. And now let's choose the radiators. So I choose the radiator tab, and in this first system, and as you see, this first system will be very, very simple, which I also recommend to you. If you start to learn the program, please start with pretty simple system. Learn how to design the very simple, very small system, and that will be easier than to go as the next one. It may be more bigger system, because it may be a little bit tricky to start with the very big and complex system as the first one. So let's say that we would use this plate radiators with the side connection. Wherever you can see this button with such a black triangle in the right bottom corner, it means that it's a pull down button. We can pull it down, and as you see on this, we've got here a list. However, we've got only 2 positions. First position is the radiator, but without any specific symbol. And then we've got the possibility of adding or deleting the positions from this list. So now you can choose a radiator. As you see, there are a lot of radiators. Let me explain you this asterisk. As you see, in case of some radiators, you've got the asterisk. It means that it's not a specific radiator, but it's a type set. So, for example, the number of plates can be different. So it's up to you whether you select already the specific radiator, for example, with a specific number of plates, or you let the program to decide for that. For example, we've got here radiator, Pulmo radiator, H, the asterisk, so the real number of the plates can be selected by the program. So I copy, and it's on my list. And now when I pull this button again, I can choose already this radiator. And it's better because now when I draw the radiators, these radiators already possess the symbols. Otherwise, it's also possible to enter the symbols later on. However, that would be more work. And now I can select these radiators, and underneath I can see the table with some additional data. This data must be entered in the tables. Luckily, we've got already the types because we have selected them. Now we can select the size. However, in case of the typesets, because we don't have the information about the amount of plates, so even more we couldn't enter the length. So here the only possibility is 0. 0 is a symbol information for the program that should be able the program should select the size of radiators. Then we've got the percentage of the heat load provided by the specific radiator, because here we've got one radiator in one room. So we enter 100%. If we have more than one radiator in the room, then we can split the heat load of the room, 50-50, or we can select the other proportions. The only condition is that the total percentages of all the radiators in one room must add up to 100%. Then we've got the correction for the positioning. If we've got the typical positioning under window, under window, so it's 1. In case of other positions that are not so favorable, we use the other values. That would result, in fact, in selecting 10% bigger radiators. And the same for the screening. If we have radiator that is not hidden, that we don't have any obstacles for air to flow around it, it's 1. In case of some screenings, we can use from this table a specific value. I can copy it. As you see, the copying works here. And the next column is the maximum length of radiators. We've got possibility here to write 0. 0, it means no restrictions. However, in real life, it's rather a rare situation. Normally, we've got a specific length that can be used for the radiator. So let's write, for example, 1.5 meters. The other information is beta. Beta is for information only for one pipe systems. And then room, we use only this column if the element of the system, in this case radiators, in another room, that it results from the drawing. Because in case of some complex system, it may be a little bit difficult to design it in exactly that way, but in majority of cases, we leave this column blank, and the program can just decides, analyzing the diagram, which room this radiator belongs to. So we enter the data about the radiators. We also should enter the data about the rooms. Let's write some symbols, and for example, let's say this is 20, that would be 24, that would be 8. And then we've got the calculation heat demand. Let's write here. And then let's say that it's unheated. Then some additional heat gains, normally there are 0, and we can also write that this is the kitchen, this is the bath room, and this is the cellar. Okay, so we've got radiators. We would also need the heat source, maybe the hanging boiler. And now we need the pipes to connect them, so I choose the tap pipes, and I start with the supply pipe first. And now I draw the return pipes. And again, we also have to enter some data about these pipes. So the first column is the type, whether it's return or supply. It's already filled in because it depends which pipe we selected from the using appropriate button. And then this is type A, which is correct. And then we've got two additional not obligatory columns, riser and pipe run. That gives us the possibility of entering the numbers, the numbering. However, it's not obligatory. Normally we just leave this, we just skip these columns. Then we have to select the isolation level, for example, here 0 if we have unisolated pipes. Then the diameter, we can select the appropriate parameter, diameter. However, if we want the program to select it, so we choose 0. And this, to inform these two zeros, we have to copy. So as you see, we can do it pretty fast. That was a bit, too big. Okay, and now we've got the length. What about the length? Should we enter also the length? It's green, it means it's not obligatory. However, it really depends on the pipe, whether it's vertical or horizontal, because in the diagram, normally we try, as we said, to keep the vertical scale. So it's obligatory only to enter this the length for the horizontal pipes, because they are normally different than it would result from the drawing. And as you see, this the drawing is dynamically related, connected with the table. If I go to another row in the table, an appropriate pipe in the diagram changes the color. So let's start with the first one. As we see, this is the horizontal pipe, so we must enter something, for example 1 meter. And then the second row is for the vertical pipe. So we assume that with the appropriate preciseness, the length the program can read from the diagram is as in the real life. Then again, vertical, so sorry, horizontal, so I enter, then again. Okay, so as you see, quickly I entered the lengths of the horizontal pipes, and then it may happen that there are some bands that we can't see on the diagram, so we've got this possibility here to add some additional bands that are not seen, because all the bands that program can recognize from the drawing, program can do it automatically. We only have to add this additional that, because as you see in the diagram, it may be drawn as one pipe, but in the real life, in your boiling room, it may happen that it goes around the walls and that there are these two additional bands. Okay, and let's assume that we have forgotten to add valves. I do it purposely to show you what would be the result. And let's start to calculate. Let's check whether this data that I entered are enough to carry out the calculations. As you see, the program checked data, but there were some errors disabling the calculations. So we have to check them. The program suggests to show us the lists. We can use it. However, we can also see the diagnosis in the table. We can use this tab list of errors. And as I see, this is the regulations of the system, and if this is the regulations of the existing systems, we can't ask the program to select. That would be possible only in the first and the second variant, so just the variant is not appropriate. I can check it. And I try the calculations again. And as you see, now we've got the different situations, because there is one error, but it's not an error disabling the calculations. The calculations were carried out, but the program checked the data, and we've got this problem that radiator in the room 1 exceeds the maximal length with 30 centimeters. So we can now click and see exactly, this refers to this room. As you see, here the heat load is, now I have changed into the results with the drawing, because we've got two drawings. We've got the drawings with data, and here we've got, for example, the length of radiator 0. So after carrying out the calculations, better to switch into the drawing with the results. And here we can read. And as you see here, the radiator is 0.8 meters. And we entered that the maximum length is only 0.5. So now we have to do something. We have to check whether it was really the maximum length. Maybe it's possible to make it a bit higher, a bit longer, or maybe we have to look for another type of radiator, or maybe we have to design 2 radiators in this room. We have to do something, but we've got this warning that there is a problem. And as I told you, we have forgotten the valves, and I expected some errors with the problems of balancing, maybe because the system is pretty low and program has got some criteria, so after an analysis it occurs that here this problem is not so big. However, to show you how it should be done in a proper way, let's also look for a valve, radiator valve. And here you just have to... it depends, because I know that in different countries we use this double valves with the thermostatic function and a balancing valve within one valve, and in some countries the other solution with two separate valves are preferred. So it's really up to you. The program hasn't got any restrictions in that area. Only that if you would like to balance the system, especially the big system, you need the valves with the possibility of balancing, with the possibility to select the appropriate preset. Oh, maybe let's try this one. It should... Here we've got the valve, and it's also good to connect the labels, because then we would be able to read the information in case of valve is especially the selected the preset. It's also not bad to connect the labels to the pipes, so we can see the diameter here. Maybe one label is enough, because most probably the diameter of the supply and return pipe would be the same. So now I press this calculator again, or the key F9. We've got the calculation. Now we've got... Okay. Now I have selected the symbol to this short list, but then, as I already told you, I entered these valves, but without the specific symbol. So as you see, if you forget it, then you can also add it later on. However, it's a bit more work, because then you have to enter it separately for all the elements. I try again. Yeah, we've got only this problem with the length. And as you see, again, in this picture with the data, you can't see the result yet. So we press this blue button, result drawing, and you can also check the presets. And for example, for this valve, we've got preset N, and for the other preset 4. These labels are overlapping a little bit. Why? Because I haven't drawn them very precisely. So it's easy to correct that. I have just to come back to the data with drawing with data. Yeah, I adjust the position of the label. However, if I go back to the drawing with the results, it's still with this overlapping. Why is that? Because the drawing with the results, it's creating during calculations. So first I have to start calculations again, and now, as you see, it looks better. Yeah, and as you see, this bigger radiator has got preset 6 and the smaller preset 4. So now really more water would go through this left radiator, because we want to design the pump system. So we have also to draw the pipe. Let's say that on the supply. So it should be like that. And then we can check the calculation results. First, we've got the general results, so the main synthetic information about the whole system. Then we have also about all the rooms, pipes, radiators, and so on. And the program also enables us to design the systems with underflow heaters, and I would now like to present it in a short way. So let's open the example 5, because it's already with these radiators. And really the designing such system has got two steps. First, we design the construction, the types of the radiators, because in case of the convection radiator, they are designed in the factory, and in case of underfloor heater, we've got more flexibility. We go to data, and we've got here the command underfloor radiators types. We can decide types. Here in this example, we've got two construction, two types, one with marble, one with terracotta. And then you can enter here, and we put the whole information about the construction. So the layers above the pipes, underneath another table with the layers under the pipes, the type of the pipe, the range of the diameters that we allow, and so on and so on. And what's interesting, we can already do the preliminary calculation. We can enter the supply temperature, and with this simple calculator we can already check whether this construction, this type is appropriate. We can, for example, check the floor temperature, which is in this example is 28.1, and so it's not too high. And then later on we draw these radiators in our diagram. As you see, you can even mix them with the normal radiators. And then in a very similar way, like you enter the data for the convection radiators, you can also choose the type of our radiators and choosing between these types that we have entered in the previous step. Okay, Mr. Ladislav asked that has got the problem that radiator size in the room 1 is not given. I think I can simulate and show you this problem, the solution. Probably you have this situation like that. You've got a radiator, and here you probably haven't entered this 0. Probably it's like that. And when you try, yeah, probably you've got exactly this this message. So what you have to do, you just have to click this. Yeah, you can go to this tab. When you click, so the program just highlights the appropriate radiators, and if you've got hundreds of radiators in the system, that's very useful. And now we select it, and we have to write this 0 here. And if you have the same problem in the second room, so you have to write this 0 also in the second room. So that was within this short presentation of about 1 hour, and now I am ready to answer all the questions that may have arisen during the presentation. And because you have the possibility of asking questions in the form of writing, so I think I have to give you a few more seconds to be able to write the questions. There's a question, if I understand it properly, if we can design the floor and surface system. Yes, at the moment we can design the underfloor to floor heating system, and also we've got this element of the wall radiators. And there is a question, how do you design the horizontal part? I'm not sure if I understand this question properly. In case of a simple system, it looks this horizontal pipe. So if I understand properly, so it looks like that. However, sometimes it may be necessary to design it in a bit more complex way. So to do something like that, for example, maybe this was a bit too big. If you've got a T-junction, yeah, you can write 0 for this, because this pipe really doesn't exist in real life. This is only in a diagram. About the heat load of the room, this program doesn't calculate the heat load of the room. For that, we can use our program, which is for the heat load calculation. But to the Kan C.H graph, you have to already enter the data, or the program can read it using the appropriate file from the program Kan HDC. So these two programs are in a kind of package. So normally you calculate the heat loads of the rooms in this first program, and then you design the system with the Kan C.H. Mr. Adrian asks how can we get the program. This program that we speak about today, so the Kan C.H is distributed by the Kan company, so please contact your local representative of the Kan company. Then a little bit difficult question to answer me in a very short way. Which manufacturers are supported by the program? Generally, if we speak about the production program of the Kan, so this is the program dedicated for the Kan company. So first of all, Kan company, and then in some other areas, for example, in case of the radiators, we've got a lot of other companies. If you are interested, you just have to choose one radiator, pull it down, and then we can, at the moment there are, as you see, quite a few producers, and you just have to check whether the producer that are interesting for you is included. And there's a question which I'm not sure how to answer. Okay, so you call it a radiator. Of course, it's a kind of simplification, because as you know, in many cases, we've got not only radiation, but first of all, convection, heat convection, and that makes it a little bit problematic, because in English language, as far as I know, in majority of cases, this word radiator is used. Probably it would be more correct, more appropriate to use the word heater. However, as we know, in many speaking countries, first of all, it's used this word radiator, even if we've got more than 50% of the convection. And then we can speak also about the underfloor or floor radiator, wall radiator, convection radiator, which theoretically even excludes itself. Then there was a question about the putting radiators and pipes in the architecture drawing view. Okay, so let me present you that. So let's switch to example 5 again. You've got, what you do is that you import the architecture plan view, and then on this plan view you draw the system again. You've got the specific table which is for plan views, and you've got here again the pipe, supply, return, one pipe, also valves. So it's important, the program allows on the plan view to use only these elements from the start plan views and also from the graphics, because these are the graphical elements without any meaning for the program. And for example, this is the radiator. The radiator in the room, in the plan view, looks like that because it's from the top. And then you've got this tool to link, to show which radiator in the plan view is which radiator in the diagram. You press it and then the cursor shows 1, so it means you select the radiator, the first element from the pair. It may be radiator but other elements as well. Then you go to the diagram and you click again and you show that this radiator is this one. And thanks to that, after fulfilling the calculation, we can read this data. For example, the diameter, the selected diameter of the pipe, in this case, for example, 14, the size, and in case of the drawing with the results, the program draws the radiators in the right scale. So we can even graphically check whether this radiator is not too big for a specific room, whether it doesn't go to another room. And also we can read this information about the underflow radiator. And then the question was about AutoCAD. You can import the drawing from AutoCAD, which is DWG. But the only limitation at the moment is that it must be versioned up to 2000. However, it's not a big problem because with AutoCAD you can just save it in that version. If you don't possess at the moment AutoCAD of your disposal, there are also the free tools to convert the DWG files into the appropriate format. Okay, so I think I will wait a second, maybe some more questions arise. And if there are no more questions within a few seconds, then yes, there are a few more questions. Is the software able to recognize the AutoCAD lines, or do we have to draw them? In this program, the AutoCAD files are treated as drawings, as kind of to draw installation on them. So the program really doesn't analyze these lines. We only see them as drawings. However, we rather don't draw on them. We don't repeat these lines from AutoCAD. They can be used. So in this case, the program recognizes them. We only draw the system. So as you see now, I think pretty easily you can recognize which lines come from the AutoCAD file and which were drawn in the Kan C.H program. How do I import DWG file? you go to the table graphic, and then we've got this button picture, insert picture, and you can choose from file. And now if you find the appropriate DWG file, you import it. However, you have to choose the units, because as you know, the files in AutoCAD, the drawings in AutoCAD are drawn in a specific units. However, in AutoCAD, there isn't this information which units were assumed to be these basic units. Normally, there are centimeters, and you have to choose this information. The program helps you with that, because if you choose meters, then the program says that this picture in the real scale would be over 1 kilometer by 1 kilometer. So of course I wish you have such designs, because then you can design just one system for one building, maybe split it in a few systems, and then probably you can get retired and you've got enough money for the rest of your life. However, probably it shouldn't be the first. As I told you, the first example should be rather smaller. So I choose into centimeters. Now we've got 12.9 times 14.5 meters, which is right. So I choose it. Then we've got this preliminary preview. We can edit layers, and for example, we can imagine that some layers from the AutoCAD are not necessary for us, for example, dimensions, so we can switch them off. And once we are happy with this drawing, we can enter it somewhere. The question is there isometric view? No, there isn't. A program only uses the plan views and the diagram. Then there is a question whether the program can analyze and recognize the pipes of the parts of the systems, such as pipes, drawn in AutoCAD. The program hasn't got this functionality. You can only treat the AutoCAD file as the architecture view. Of course, as you suggested previously, if you import it with the pipes already drawn, you just have to draw them again, which should be easier. However, you have to do this work again. So the general idea is to draw the system in the Kan C.H program, not in the AutoCAD. Later on, you can export it. You've got this function save as DXF or DWG file, and then you can export your results drawing from Kan C.H into AutoCAD. Mr. Ladislav writes that has saved the AutoCAD file into AutoCAD 2010, and again there is a unsupported version. Okay, because it should be 2000, not 2010, but AutoCAD 2000, and then it should work. There is a question whether the floors, the different floors, should be centered to each other. In this program, we don't have really the connection between the floors, so you can draw the floors separately. It means that you don't have to adjust one floor to another one. Okay, so if there are no more questions, so thank you very much for the nice meeting. Oh, there's still one question. How can we get support in future for using the program? So you've got two possibilities. Depending on your question, you can contact the representatives of the company, and if you've got very technical questions connected with the software, you can also contact us, Sankom company, which produces the program. You can find our email address at our website sankom.pl or sankom.eu. Are there any more questions? So thank you very much for the very nice comments. It was very nice talking to you. I'm sorry that I couldn't meet you personally, but maybe in the future we'll have this opportunity. And I wish you a lot of successful projects in future, hopefully using our software. Thank you very much and have a nice day to all of you. Goodbye.